All right. So we are still doing coordinate geometry, but what we were doing before was straight line geometry, right? Now we're doing circles. But still under the heading coordinate geometry. So what we're focusing on when we're looking at circles, we're going to learn how to write the equation of a circle. We're going to learn about tangents and normals and the intersection of a circle with a straight line. These are the syllabus objectives. So equation of a straight line, determine the center and radius of a given circle, determine the equations of tangents and normals at given points on circles, and determine the points of intersection of a circle with a straight line. So what we're focusing on today are these two objectives up here. This one and this one. Oops. Right. So some things you need to note. These are some formula you need to note. I don't know if you probably did it in math already, but I will do it to you still. So the first one is Pythagoras' theorem. Pythagoras theorem. Hold on, give me a sec. Right. So when given a right angle triangle, so it always has to be right angle. Right, so this is my right angle writing. Pythagoras' theorem allows us to find any side of a right angle triangle given two other sides. Okay, so this line here, we highlight it in yellow. This line is called the hypotenuse. So let me just put the H there. Hypotenuse. Hypotenuse. So the hypotenuse is the longest line in the triangle, right? This other side, I'll name it. Hold on, let me highlight it as well. Let me highlight it. That line, we'll name it A. On the last line in this triangle, let me highlight it purple. Green, purple. We'll name it B. But these letters don't matter, right? It could be any letter you want it to be. The most common though are H for hypotenuse, A for this side, and B for base. So you can just remember that, right? And Pythagoras' theorem states that the hypotenuse squared, so H squared, is equal to A squared plus B squared. And this equation here, this allows us to find, just underline it, this equation here allows us to find the length of any line in a right angle triangle when given two of these lengths. So say they told me that the hypotenuse was 3 meters, so let me put it in white. They told me this was 3 meters, and they said this was 9. Actually, no, that makes no sense because the hypotenuse should be longer. So let's say this is 6 and this is 2 meters. Looking at this formula, all I have to do is substitute the values. So they told me H is 6, so I put 6 squared here is equal to A. They told me A is 2 meters, so I put 2 meters here, 2 squared, plus B squared. What we're trying to find is the length of B. That's B squared there. We're trying to find the length of B, so all we have to do is transpose. Transpose means making B the subject of the formula to find out the value of B. So 6 squared is 36, is equal to 2 squared is 4, plus B squared. I can minus 4 on both sides. So let me just write this out. 36 minus 4 is equal to b squared. 36 minus 4, 2 is equal to b squared. Remember when I told you from a previous class, when finding square roots of any number, unless told otherwise, is always plus or minus. Anybody remembers that?
Yes, miss.
Right. This was one of the cases I was talking about. You can't have, I can't tell you, okay, I have a piece of ribbon and this ribbon is minus 5 meters. That makes no sense. You'll never have minus a length. So this is one of the cases where the square root of the number would always be positive. So no need for the plus or minus, it's just the square root of 32. And that would be, wait, somebody is saying something?
Miss, the answer going to be 5.6.
Yeah, in your calculator, that's what the square root of 32 is?
Well, yeah.
All right. Well, yeah, 5.6. 5.6 meters. Everybody good with that?
Yes, miss.
This is just something you need to know before we start this topic. But I think you have done this in math already. Just in case you forgot. All right. Next one. Next thing you need to know, the distance. Okay, so when given 2 points on a line, let me draw a line. Okay, so say this is, no, yeah. Say I'm given this line. Pretend that's straight. It's supposed to be straight. And they told me this point on the line here, the end of the line is x1 and y1. That's a 1. So let me just. That's a 1, eh? Right. And then they told me this point, the second point, the other end of the line, has the coordinates x2, comma, y2. Remember, the form for any coordinate is x, comma, y. Okay, so they gave me this line here, and they told me this point at the end of the line has the coordinates x1, y1, and then this other end of the line has the coordinates x2, y2. If a question tells me to find the length of this line, I can't use Pythagoras' theorem. Why? This is not a triangle, and to use Pythagoras' theorem, you need at least 2 sides, right? So this is the formula you use when given 2 points on a straight line and they ask you to find the length of the line or the distance between 2 points. It means the same thing. So D means distance, is equal to the square root of x2 minus x1 close bracket squared plus y2 minus y1 close brackets squared. Anybody ever saw this formula right here before?
Yes, miss.
Yes, miss.
All right, nice. And midpoints, that's the last thing we need to know. Say I have the same line, and they give me 2 endpoints. This endpoint here and this endpoint here. This is still x1, y1, and this point is still x2, y2. If I wanted to find the midpoint means the middle of the line. So this coordinate right here, we just know it's in the form xy. Remember, point, let me write it, point means the same as, so this means, that sign means equivalent to coordinate. So if they are ever asked for a point, they mean a coordinate. And a coordinate is always in the form, x, comma, y. If they want the midpoint, this is the formula you have to use. So midpoint is equal to x1 plus x2 divided by 2. So this would be my x value. This would be my x value, comma, y1 plus y2 divided by 2, put your close brackets, and this would be my y value of the coordinate. Let me show you an example. So say this coordinate down here was 3, 2, and this one was 8, 8, 7. If I wanted to find the midpoint of this line, so I want to find this dot right here, x1.
Just substitute the values.
Good job. So x1 is 3 plus x2 is 8 and 2. Y1 is 2, and then y2 is 7 and 2. Continuing here, 8 plus 3 is 11 on 2, comma, 2 plus 7 is 9 on 2. And I could just leave it like that. So this would have been my answer for the midpoint. Everybody good with that?
Yes,
Yes,
miss.
miss.
All
Yes,
right.
miss.
If you're not good with that, let me know.
Miss, I have a question.
Okay.
Can you put it in like decimal format where you just have to leave it as 11/2 and 9/2?
You should leave the exact form if they don't ask you to approximate it, because technically, hold on, what's a decimal? Unless it's an exact decimal, so 9 on 2 is the same as 4.5, that's okay. But if you have a decimal, that's like 4.23456, whatever, and then you just put 4.23, technically that answer is wrong because it's not the exact value, right? So, oh my, what did I do?
Okay,
What did
miss.
I do? All right. So let me just finish with this. So if it's a exact decimal like this, fine, do that. If it's not an exact decimal and you have to round off, unless they tell you to, don't do that. Because technically your answer would be wrong. Okay. Now that we finish all this, so make sure you know these. Oh wait, I need to show you this too. And this is what it will look like for the circle. So you remember the line I showed you just now with one endpoint and the other endpoint and then the midpoint? This line, could somebody tell me, is that this line, this whole line here, is this a radius or is it a diameter?
Diameter.
Yeah,
Mhm.
diameter.
Yep. So for questions dealing with circles, you'll probably find this. I'll show you later on. They might give you the diameter and then you'll have to find the radius and all that. And that's why you would need to know these equations. You need to find the length of the diameter and then you have to divide it by 2 to find the radius and so on. I'll show you that later. So just make sure you know these. Okay, there are two forms of a circle. There's the standard form and the general form. But right now we're dealing with the standard form of the equation of a circle. So consider the circle below with center HK. There's the center right here, and radius R. This is R. There's also a general point in the circle whose coordinate is XY. XY. The standard form of a circle is x minus h squared plus y minus k squared is equal to r squared. Now let me show you now. See these asterisks here? I need to show you something just now. But before we do that, let me show you something else. If I made a right angle triangle here. So I draw this vertical line and I draw this horizontal line. Isn't this a right angle triangle?
Yes, miss.
Anybody remembers what the formula for gradient is?
M is equal to y2 minus y1 over x2 minus x1.
Good job. X2 minus x1. But this could also be written as the difference. So I'm just going to put the difference in my y values s divided by the difference in my x values. It makes sense. Why? Difference, oh my gosh. If you say the difference of two values, that means you're going to subtract it. It's implied that you're going to subtract those two values. So by saying the difference in my y values, I'm saying that I'm going to subtract my y values. By saying the difference in my x values, I'm saying that I would subtract my x values. Everybody good with that so far?
Yes, miss.
All right. So that's why this horizontal line, actually let me start with the vertical line. This vertical line, the difference in my y values, this, in this case, this one, this would be considered in this case, this coordinate here, this general point, would be considered my x2, y2, in brackets. And this point, the center here, is my x1 and y1. If you don't understand what you're writing, let me know because, right. So this vertical line here, let me get my laser pointer. This vertical line here would represent the difference in my y values. Difference in my y values means y2 minus y1. In this case, let me get the highlighter. Y2, looking at this coordinate, y2 is y, and x2, and y1 is k. So if I wanted the difference in my y values, so that's y2 minus y1, then it would be y2 is y minus y1, which is k. Doing the same for this horizontal line. This horizontal line would represent the difference in my x values. Difference in my x values means x2 minus x1. We said, hold on, I need my highlighter. We said that x2 in this case is x and x1 is h. So what we write in here now, this horizontal line represents x2 minus x1, so it's x minus h. Anybody remembers what Pythagoras' theorem is? Hold on, wait, let me erase. Okay.
A squared plus b squared is equal to c squared.
All right. Yeah, I forgot to mention that too. Hold on. Let me just erase all this so I don't confuse you. Erase. Pythagoras' theorem. Wait, let me go back to that slide. Hypotenuse squared is equal to a squared plus b squared. That's just one way of writing it. You might see elsewhere a squared plus b squared is equal to c squared. Or you might see a squared is equal to b squared plus c squared. It all means the same thing, right? One is the hypotenuse, one is, oh my gosh. Let me draw the triangle again. So that's my right angle triangle. It doesn't matter. One is the hypotenuse. So looking at this, one is the hypotenuse, so I'll just name the hypotenuse C in this case. This side and then this side. It all means the same thing. So whichever you prefer. Just label the three sides something, right? Okay. Let me get a highlighter. Okay. This is the triangle I'm looking at. Everybody seen that triangle, right?
Yes, miss.
All right. And these are my three sides. Oh, already. Okay. So I have this. R is one side of the triangle. Y minus K is the other side. And then X minus H is the third side. Everybody seeing that?
Yes, miss.
All right. And Pythagoras' theorem, we just said, I'm just using this one. So hypotenuse squared is equal to a squared plus b squared. Let me draw a triangle again to remind you of which is which. So this is my right angle. Remember, it's always a right angle triangle. This is my hypotenuse, is the longest line. This is A, and this is B. B for base. Right. So what's my, looking at this triangle, which one is the hypotenuse? This, or this?
R.
R. So that's R squared. Oh my. Bear with me, R squared. Right. I'm looking at this triangle. I said that A is this side. So now can you tell me which one is A? A is this side right here. So which one is A? Y minus K or X minus H?
And Y minus K. And B would be X minus H.
So what I would write? Y minus K squared plus X minus H squared. But this could be rewritten as this right here. Hold on. Let me write it on the blackboard so you can see it more clearly. So I have Pythagoras' theorem, hypotenuse squared is equal to a squared plus b squared. We said that the hypotenuse for that triangle was r squared. Well, the hypotenuse is r, so it's r squared. A was y minus k, so we put in y minus k squared plus b, which was x minus h, so we squared that. But what I was saying just now, this could be rewritten as, let me go back to red, r squared is equal to x minus h squared plus y minus k squared. And if I wanted, instead of putting the r squared on the left-hand side, I could put it on the right-hand side. So x minus h squared plus y minus k squared is equal to r squared. So this right here is what we're looking at. So write it down, memorize it. I want to show you something. Let me know when you finish with this. Just remember this formula right here. I want to show you something. Let me know when you finish, yeah?
Mister, could you repeat what you're doing?
Just, if you want to write this down, write it down. You don't have to, you don't really have to if you don't want to. I just wanted to show you something. But when you finish with this, let me know.
Almost when I finished, I was taking it down while I was writing.
All right.
Yes, miss.
Anybody else? Okay. So looking at this, I have in brackets x minus h squared plus y minus k squared is equal to r squared. Remember that. Now look at this. Isn't it the same thing? Yes or no?
Yes, miss.
Yes, miss.
I just wanted to show you how they got that. So you don't necessarily have to memorize how I ended up with this. I just wanted to show you to help with your understanding. All right. Now for the reason why I have the asterisk here. Note, in past papers and in the syllabus, instead of seeing a minus sign here and a minus sign here, you see two plus signs, right? And in this case, remember I told you that the that the center of the circle was HK. The center is HK when using this formula. So the minus and the minus. When using this formula, you add it instead of using the minus, you put a plus sign. The center is no longer HK. The center is now minus H minus K. All right. So this is the one, this equation here is the equation we would be looking at for this whole topic. So you're probably wondering if this is the equation we're looking at, why I showed you this. I showed you this to help you with your understanding. But what you should learn is this one, because this is the one you see in past papers, right? Don't worry if you're kind of confused as to what's going on right now. I would show you. We're going to do some questions. I will show you what I mean, right? So we good? Yes, no? Confused?
Yes.
Yes, miss.
All right, if you're still not sure what I was talking about here, it's okay. I'm going to practice. I will show you then. Okay, you could leave and rejoin because you only have less than 3 minutes left and I need to explain. So just rejoin.